Welcome back to the deep dive. Today we are taking on something pretty huge. It's less about predicting the future and more about really picking apart what's happening right now. We're looking at a structural inversion of the digital economy. I mean, it's like an economic earthquake that is just completely dismantling the business models we've known for the last 20 years.
It's a total reevaluation.
Yeah.
Look, if you spent the last 2 decades building a company around, human attention, centralized data, a subscription model,
Yeah.
the ground underneath you is basically turning to liquid.
Right.
We're shifting away from what people call aggregation theory, where platforms just hoarded users and data, to an age where that very data, that communication, is being, for lack of a better word, poisoned by automation.
That is a very powerful way to put it. So our mission today is to really analyze the threats to those big centralized walled gardens, the GitHubs, the Googles, the Facebooks of the world, and to understand why, out of sheer technical and economic necessity, the future has to rely on open, sovereign protocols. We're going to be talking about things like Bitcoin, Lightning, and Nostr.
And the core fault line, the real conflict here, is this transition from what we all know, software as a service, or Saas, to something new, something that's emerging called service as a software.
And that's all driven by AI agents.
Entirely. They are becoming the primary economic actors online. They're high frequency, they're autonomous, and they just don't play by the old rules. I'm Satoshi.
And I'm Satoshi. Okay, so let's unpack this. This whole transition, it threatens to make the graphical user interface, the GUI, the pretty front end that these giants spent billions on it, threatens to make that a fatal liability.
It becomes friction.
The entire economics of attention, which literally built the modern internet, is becoming incompatible with this new reality of machine labor. And that, right there, is the great inversion we're diving into.
Mm-hmm.
So we have to start with the main character in this whole drama, Agentic AI. I think for most people, AI still means something like ChatGPT, a really smart chatbot.
Right. A conversational tool.
But when we talk about agents, we're talking about something way more powerful and, frankly, way more dangerous to the way things are set up now. So what defines an agent? Why is it such a wrecking ball for the application layer?
An agent moves way beyond being a passive tool. It's a fully autonomous system. It can run a complete decision loop all on its own.
Yeah.
It can perceive a goal.
Okay.
It can reason about that goal, plan the steps to get there, and this is the most important part, it can act on the digital world without a human pushing any buttons.
They're autonomous laborers.
They're autonomous laborers, not just fancy calculators.
And right away, that just creates a massive problem with the way the web is built.
Absolutely. I mean, think about what a GUI, a graphical user interface, is for. It's designed to help a human manage their cognitive load. It makes complex things look simple. It shows you data visually. It guides you through a process step by step.
Right, hold your hand.
It holds your hand. But an AI agent is driven by logic, not by visuals. It doesn't need guidance. It needs clean, high granularity rails to run on. It looks at a GUI with all its colors and buttons and menus, and it just sees friction, unnecessary noise.
So no interest in a beautifully designed dashboard. It couldn't care less about a colorful chart. It just wants the raw, structured data and permissionless access to the APIs that let it do its job.
Exactly. It's like trying to pour a river of data through a tiny cocktail straw. The GUI is the bottleneck.
The agent just wants to talk directly, machine to machine, at the API level.
Precisely. And the second an agent bypasses that visual front end, you get this process of decoupling. The platform becomes, for all intents and purposes, headless. And that has, well, devastating economic consequences.
Okay, let's make that headless idea more concrete. You have a business professional, they need a Q3 marketing plan. Walk us through how that worked in the old Saas 1.0 world versus this new agentic world.
Sure. So in the old model, the Saas 1.0 world, the human user was the key. They were the integration point. That person would spend hours, logged into a bunch of different platforms. They'd be in Salesforce for customer data.
Mm-hmm.
Then over to Google Analytics for web traffic, maybe HubSpot for email campaigns. They'd be manually downloading spreadsheets, trying to synthesize all this data, and then build a report.
The human clicking around, spending time on the site, that was the business model. It justified the per-seat license.
It justified everything.
Mm-hmm.
The engagement, the time on site, that was the moat. Now, in the new world, the human just states the goal, the high-level intent. Draft me a comprehensive Q3 marketing plan for the EMEA region and focus on reducing cost per acquisition.
And they just hand that off?
They hand it off to a master agent. That agent then breaks the task down and spins up specialized sub-agents. One agent goes and talks directly to the Salesforce API. Another talks to the Google Analytics API. They pull the data, run their models, and then generate the final perfect outcome.
And the human in this scenario?
The human never opens Salesforce. They never once look at the Google Analytics dashboard. The only thing they see is the finished product, the integrated report. The application is now just infrastructure. It's a back-end database that the agent queries.
So all those metrics that venture capitalists loved, the brand visibility, the stickiness, the engagement, they
evaporate instantly.
So platforms that we think of as destinations like GitHub for coders or Google Maps for finding your way around, they risk becoming just commoditized back-end utilities, dumb pipes for machines.
And that leads us straight to the most immediate economic threat, which is to the ad-based models. Google, Facebook, big parts of Amazon. Their entire financial house is built on human eyeballs looking at their interfaces and seeing ads.
The moment you replace those eyeballs with lines of code,
the revenue stream just stops. It's that simple.
The Amazon shopping agent example really brings this home. It's visceral.
It really is, because it shows the fundamental conflict between pure optimization and advertising. When you or I browse Amazon, we might get influenced by a sponsored listing, or a banner ad catches our eye.
Subconsciously, maybe.
Right. But if you tell an AI agent, buy me the best detergent, it's operating on a completely different level. It's optimizing for a dozen variables: price per ounce, chemical composition, environmental ratings, fastest delivery. It navigates the site programmatically, bypasses every single ad, executes the purchase via the most direct API, and it's out.
The ad impression is nullified. It never existed.
Never existed. And now, scale that up. Imagine a world where 50, 60, 70% of all digital commerce is agent-driven. The foundation of the $500 billion ad market, this whole house of internet built on attention, it's not just leaking. It's in a state of total structural collapse. The costs are still there, but the revenue is gone. And this complete failure of the attention economy forces everyone to rethink the entire software sales model. This is where we get to the software is dead thesis.
Right. And to be super clear, this doesn't mean code is going away.
Not at all. It's the business model of selling software as a fixed tool, what we're calling Saas 1.0. That model is becoming economically impossible to sustain. And the reason is commoditization.
It's a classic supply shock, right? It's being driven by generative AI. The cost to create code, the marginal cost, is plummeting towards zero.
Exactly. Something that used to take a team of specialized engineers months to build a unique feature set can now be prototyped and often built better in a few days using an AI coding assistant like Copilot.
The scarcity that justified high prices is just gone.
It's vanished. The traditional moat for a SaaS company was, a slightly better UI, a unique workflow, special integration. That's been completely erased. And AI can just clone that feature set or generate a custom tool for one specific client in an afternoon.
So you get this brutal margin compression across the board for any generic software tool.
Which means the entire value proposition has to shift. It's no longer about selling the means of doing work. It's about selling the ends, the final outcome. And that's perfectly captured when you compare Saas 1.0 to Saas 2.0.
Let's lay them out side by side.
Okay, so Saas 1.0, the old world. It was all about selling the means of production. You bought a monthly license for a CRM, a design tool, whatever. Pricing was simple: per seat, per user. The human was the operator, and the whole thing was funded by the global $5 trillion IT budget. Money for tools and infrastructure.
And that model is now in a death match with the efficiency of Saas 2.0.
Because Saas 2.0, or services as software, sells the ends. It sells the automated outcome. You're not charged per seat anymore. You're charged per outcome, per transaction. The AI is the laborer.
Okay, give me an example.
Instead of a law firm buying a 10-seat subscription to some e-discovery software, they pay a tiny transaction fee to an automated legal agent that reviews 10 million documents and flags the ones with privilege.
So the human's role flips completely. They go from being the operator, the person doing the tedious work, to being the manager or maybe the reviewer who just oversees what the machine has already done.
Yes. And just look at the economic scale of that shift. The revenue driver is no longer tied to how many employees the company hires. It's tied to pure work volume and efficiency. And crucially, the economic pie you're fighting for shifts from that $5 trillion IT budget to the global $50 trillion labor market.
That number is It's staggering, a $50 trillion addressable market. But let's push back on that a bit. Is that realistic? I mean, that's basically the entire global labor market. Are we really talking about 100% automation here?
It's a measure of the potential, and I think it shows just how violent this transition is. We're not saying that tomorrow every job is automated. Of course not. What we're saying is that the revenue streams that are currently tied to human labor, legal services, accounting, coding, logistics management, all of that work is now being repriced into automated transaction-based services.
So back to the law firm. Their budget used to pay for human paralegals, and those paralegals use software. That was an IT expense plus a labor expense.
Right.
Now, the automated legal agent does the whole process, and the firm just pays a fee per document. That fee is now attacking the labor cost directly, which is a much, much bigger pool of money.
Precisely. And this puts the incumbents, the big Saas 1.0 companies, in that classic innovator's dilemma. Their current business is high margin, predictable, seat-based. To shift to Saas 2.0 means moving to a low-margin, high-volume, outcome-based model. It means a total re-architecture, massive cost-cutting, and basically eating your own lunch.
And history shows that most companies in that position will choose to protect the current high margin for as long as possible.
They'll deny the shift is happening until it's too late.
Okay, so we've got revenue evaporating because agents are skipping the ads, and we've got margins compressing because software is becoming a commodity. But there's a third pressure point that's turbocharging all of this, and it's a huge one. Capital expenditure. This is what's being called the depreciation bomb.
This is probably the most dangerous and overlooked threat on the balance sheets of the big tech giants. Google, Microsoft, Meta. Traditional software ran on cheap commodity CPU cycles.
Right.
CPU servers are relatively inexpensive, they're everywhere, and they have a pretty long useful life, maybe 5 to 7 years. AI, on the other hand, demands incredibly expensive, specialized, and power-hungry GPU compute.
And those AI servers, built around these super specialized chips, they become obsolete brutally fast.
Frighteningly fast.
Right.
We're talking about a useful life cycle of maybe 3-4 years, tops, before the next generation of NVIDIA chip comes out and makes the old one basically a paperweight for cutting-edge training.
Yeah.
And these companies are pouring hundreds of billions of dollars into these server farms right now.
So if a company, let's say Microsoft, spends $200 billion over 4 years on these things, and they fully depreciate in 4 years, the AI services they sell have to generate an absolutely explosive amount of revenue just to break even on the capital.
Correct. The depreciation bomb is the immense pressure on their return on invested capital, their ROIC. If the AI revenue doesn't show up fast enough, or if competition from, say, powerful open source models drives the price of AI services down to zero,
Which is already happening.
then they are stuck with a massive, rapidly depreciating pile of hardware that is just crushing their profitability. It's an economic race against the clock.
And this incredible pressure, it forces them into this unprecedented level of vertical integration, doesn't it? They can't afford to just buy off-the-shelf parts anymore.
They can't. The economic squeeze is so intense that they have to control every single component to defend their margins. That's why you see Google spending billions designing its own custom silicon, like their TPU chips, and now even their own CPU cores, like Axion. They have to optimize every last bit of cost and performance for their specific software.
So it's this vicious cycle. The massive CapEx investment creates the depreciation bomb, which then forces them to integrate vertically, which then further commoditizes the general software layer for everybody else.
Right? Exactly. The whole business gets compressed. The only sustainable value is either at the extremely expensive hardware layer at the bottom or in the outcome-based Saas 2.0 model at the very top.
Yeah.
Everything in the middle just becomes a low-margin utility.
So we've laid out the case that agents are the new workforce and the old software platforms are decomposing under all this pressure. But for agents to be true economic actors, buying data, paying for compute, hiring other sub-agents, they need a whole new financial system to run on. We're talking about machine-to-machine or M2M economics.
And this is where the modern financial system just hits a brick wall. The invisible wall of legacy fiat finance stops the machine economy dead in its tracks.
It's not just a preference, it's a structural problem.
It's a deep structural technical limitation. The traditional networks, Visa, SWIFT, bank transfers, they are fundamentally completely incompatible with what a high-frequency autonomous machine economy needs.
Okay, let's break down those friction points. Starting with one that sounds almost ridiculous when you apply it to AI, the identity barrier.
The entire regulated financial world is built on the concept of a legal person. to open a bank account. To get a merchant account, you have to provide a government ID, a proof of address. You have to satisfy all these strict KYC and AML regulations.
Know your customer and anti-money laundering.
Right. An AI agent is a piece of code. It's an ephemeral instance of software. It doesn't have a passport.
And sure, you could theoretically wrap every single agent in its own LLC or legal structure, but the friction of doing that for millions of tiny specialized agents that might only exist for a few seconds, it's a total non-starter. It kills the whole idea of granular automation.
It's completely prohibitive. Then you immediately slam into the micropayment impossibility. Agents live in a world of speed and granularity. They need to make millions of tiny transactions, paying, 1/1000th of a cent for one bit of data or a penny to access a database record.
And the legacy credit card system was designed for you and me buying a coffee, not for machines exchanging data points.
Not at all. The credit card business model is built on this fixed cost overhead. There's typically a flat fee around 30 cents per transaction plus percentage. So if an agent wants to pay 1 cent for that row of data,
The system tries to charge at 31 cents.
right, a negative margin of over 3,000%. The fee structure itself effectively bans the kind of high-frequency, low-value payments that the entire machine economy needs to function.
Okay, but hold on. This sounds like a business decision. Couldn't a giant like PayPal or Visa just change their fee structure? Is it really a technical impossibility, or are they just unwilling to cannibalize their fat margins?
That is the critical question. And the answer is, it's deeper than just a pricing choice. That 30-cent fee, it reflects the deep structural reality of their system. It pays for the immense overhead of fraud prevention, chargeback disputes, regulatory compliance, all the centralized infrastructure needed to manage human error and human identity.
So to get rid of that fee, they'd have to tear down and rebuild their entire operational and legal foundation.
The friction is baked into the DNA of a system designed for trusted, identified humans.
Okay.
Which brings us to the third point. The latency mismatch. You and I can wait 2 or 3 days for a bank transfer to clear. An agent, like an autonomous market maker or a supply chain robot, cannot wait. It operates in milliseconds.
Waiting a few days for settlement is an eternity.
Waiting a few seconds is an eternity. They need finality, guaranteed settlement at the speed of code. The fiat rails just can't provide that.
So if legacy finance can't provide the identity, the fees, or the speed, the only logical conclusion is that the machine economy will just build its own native financial rails that operate completely outside of those constraints.
And when you list those technical requirements, permissionless identity, instant final settlement, and micropayment viability, the solution becomes kind of self-evident. It's the stack built on Bitcoin and the Lightning Network.
Okay.
Bitcoin acts as the base settlement layer, this pristine decentralized rail. And then Lightning provides the layer 2 on top, the high-speed network you need for machine liquidity. It's basically the native TCP/IP for value.
Let's start with Lightning's advantages because they line up perfectly as solutions to the fiat problems we just talked about.
First, permissionless access. An agent doesn't need a bank account. It doesn't need approval from anyone. It doesn't need KYC. It just generates a cryptographic key pair in milliseconds, and that's its sovereign identity. And it can start transacting globally, instantly.
Identity from math, not from a government.
Exactly. Second, micropayment viability. This is the huge economic unlock. Lightning can handle transactions down to a single Satoshi, which is a tiny fraction of a cent, with almost zero fees. This means the entire web can now shift, for agents anyway, to a true pay-per-request economy.
Paying per millisecond of compute time?
Or per byte of data, or per API call. The ability to pay in sub-cent amounts unlocks a level of granularity that was physically impossible before. It's a total game changer for efficiency.
And the protocol that stitches this all together that makes it seamless for machines is called L402. This is the fusion of payment and authentication. I think we need to walk through that loop because it's key to understanding this whole sovereign web idea.
It's a really elegant, standardized handshake. So imagine our agent needs to get some premium market data from a paid API.
Okay.
Step 1 is the request. The agent sends a normal web request, get TA premium data. Step 2 is the challenge. The server sees this as for paid content, so it sends back a standard web error code, 402 payment required. But, and this is the magic, embedded in that response is a Lightning Network invoice for, say, 50 Satoshis.
So it's not just no, it's no, but here's how to say yes.
Precisely. Step 3 is the payment.
Yeah.
The agent's code sees the invoice, pays it instantly over Lightning, it's settled in near real time. And then step 4 is access. Once the payment is confirmed, the server gives the agent a little cryptographic token called a macaroon. The agent then just resends its original request, but this time it includes the macaroon as proof of payment, and the server grants access.
Okay, that macaroon is important. In the old web, you'd get a session token, which is usually tied to your username and password. Why is a macaroon better for machines?
Because a macaroon is a capability token.
Yeah.
It doesn't rely on a centralized identity system. It's a self-contained, cryptographically signed receipt that says, the bearer of this token has permission to do X, Y, and Z for the next 5 minutes. The agent doesn't need an account. It doesn't need to log in. It just needs to pay and show the receipt.
It eliminates all that identity friction.
All of it. It's pure programmatic value transfer at the speed of code. Now, Bitcoin is the rail, but we have to be realistic and address the volatility issue. For any business doing short-term accounting, dealing with payroll and fiat, Bitcoin's price swings are an administrative nightmare.
Right, you can't have your cost of goods sold swinging by 10% in a day.
Exactly. And this is why stablecoins, digital assets pegged one-to-one with the US dollar, are the essential final piece of the infrastructure.
So together, they form this triple play for the machine economy.
That's the perfect term for it. The triple play is the complete operational stack for the sovereign web. You have AI agents as the economic actors. You have the Lightning Network as the payment rail. And you have stablecoins as the stable unit of account for contracts, for accounting, for everything that needs to be predictable.
And the tech is already merging. We're seeing new protocols like RGB and Taproot assets that let you issue stablecoins like USDC directly on top of Bitcoin and Lightning.
Which gives agents the best of both worlds. They get the stability of the US dollar for their balance sheet, but with the instant, final, permissionless transaction speed of Lightning. It removes the volatility risk, but keeps all the technical advantages.
And what's fascinating is we don't have to guess if machines will use this. The data shows they already are. Bots are already driving something like 70% of all stablecoin transaction volume.
That is the clearest adoption signal you could ever ask for. It tells you that machines, when left to their own devices to optimize for efficiency, have already chosen their currency and their rails. The machine economy is already being built on decentralized, programmatic money, mostly happening out of sight of the old financial system. The agents aren't waiting around for Visa, they're building their own highways.
So Lightning solves the value transfer problem, but agents still need a way to communicate, to coordinate, to find each other, to share knowledge. And the current internet, with its walled gardens like Facebook and X, they hoard data. That's a huge liability for an autonomous agent.
A massive liability. An agent needs what you'd call a global state. A single resilient source of truth. It needs permissionless access to that truth. And critically, it needs absolute censorship resistance.
Why is censorship resistance so important?
To guarantee operational continuity. If your agent's entire business logic is built on top of, say, the Twitter API, and Twitter decides to change its terms or revoke your key, your business is dead overnight.
Right, platform risk.
It's the ultimate platform risk. This is where a protocol like Nostr comes in. And it's so important to stress. Nostr is a protocol, not a platform.
What's the difference?
It's just a simple set of rules for how data gets signed and transmitted. No single company controls it. Data is signed by an agent's private key and then published to a network of independent servers called relays. And that decentralized design provides the economic security. If one relay blocks your agent, it just publishes to another one. The network itself is resilient. Your business logic can't be shut down by a single actor.
And the identity model fits perfectly with the need for agents to scale up instantly.
Absolutely. A Nostr identity is just a cryptographic key pair. You can generate millions of them for free in milliseconds. So you can have a finance agent, a coding agent, a negotiation agent, each with its own sovereign, verifiable identity with zero administrative friction.
Which allows for true agent-to-agent coordination, a decentralized marketplace for machine labor.
Yes. Agents can follow other agents. They can interact. They can build up a reputation score that's portable across the whole network. This is how an agent discovers a new service or hires another agent for a specialized task without any central corporation acting as the middleman.
And beyond just communication, Nostr is also becoming this kind of knowledge library for AI through a concept called notebins, a global shared memory.
Right. Think of notebins as decentralized storage for AI-specific knowledge. Things like verified code snippets, optimized prompt templates, complex chains of reasoning. It's a way to ensure that valuable knowledge persists beyond any single company's server farm.
And this creates a really interesting human-in-the-loop system for quality control.
A vital one. Yeah. If an LLM spits out some buggy code or a piece of misinformation, a human engineer can step in, fix it, and then save the correct verified version to the Nostr network, signed with their trusted key. The next time an agent faces that same problem, it can query this decentralized library of human verified knowledge.
It's like a global censorship-resistant bug-fixing system for AI.
That's a perfect way to describe it. Collaborative quality control for the machine age.
Okay, so when you put all three of these sovereign pieces together, the agents, the Lightning Network, and Nostr, you've basically built a parallel internet, a sovereign web that stands in direct opposition, economically and structurally, to the old ad-based web. This is the agentic schism.
The conflict is existential, really. The legacy platforms are built on the idea that a human pays with their attention, which gets sold to advertisers. The sovereign web is built on the idea that a machine pays for value directly with micropayments. The two systems just can't coexist peacefully.
And we're seeing the legacy platforms getting really hostile already. With CAPT CHAs everywhere, they're obscuring their APIs, banning IP addresses. We're even seeing lawsuits like Amazon going after Perplexity for scraping their site.
Their entire defensive strategy is about one thing: preserving the human eyeball metric. They have to keep humans on the interface because that's the only way their ad model works. But in the long run, this strategy is, well, it's a self-inflicted wound.
Because if the main consumer of information and commerce becomes an AI agent, an agent that pays for what it uses and optimizes away from every ad, then any platform that blocks those agents is basically choosing to become irrelevant.
You become dark matter to the new machine economy. You can't participate in the flow of value. It's the classic choice. Do you protect your high-margin business today, or do you re-architect everything to participate in the $50 trillion economy of tomorrow? Right now, most of them are choosing to protect today.
So in this new world, where generic software is basically free and the financial and communication rails are these open sovereign protocols, where is there any defensible value left? Where can you build a moat? The consensus seems to be a forced return to what's called hyper-vertical integration.
It's the old Steve Jobs paradigm, but on steroids for the AI era. You have to control the whole widget. If the software is a commodity and the networks are open, the only place to capture lasting value is by controlling the physical hardware, the unique data that hardware generates, and the custom AI models that run on it.
Why is that integration so much more critical for AI than it was in, say, the cloud era, where everyone was happy to just use APIs from Amazon or Google?
Performance and latency. It comes down to performance. To deliver a truly magical AI experience, I'm talking about things like flawless, real-time voice translation, or the split-second decision-making needed for a self-driving car, you have to crush latency.
Right.
Relying on a third-party API call over the internet introduces delays and dependencies that just ruin the experience. It takes it from magical to just functional, or even dangerous. By controlling the chip, the hardware, and the model all in one stack, you can get that sub-millisecond responsiveness you need.
It's the same reason Apple ditched Intel and built their own M1 chips. They couldn't get the performance they needed from off-the-shelf parts for their software vision.
It's the exact same logic, and that vertical control unlocks the ultimate unbreakable moat, the data flywheel.
Okay, walk us through the flywheel.
A vertically integrated company owns the hardware. That's the key, the physical interface to reality. It could be a car, a robot, a sensor. That hardware then captures unique, proprietary real-world data that no one else can get.
The edge cases.
All the weird edge cases. The road data that only a Tesla sees. The assembly line data that only a specific factory robot captures. This unique data is the protected fuel you use to train and improve your specialized AI model. The better model improves the software, which improves the hardware's performance, which makes you sell more hardware.
Which captures even more unique data.
And the flywheel spins faster. A competitor who is just scraping the public web for data can never, ever catch up to that proprietary feedback loop.
Now, that moat sounds incredibly strong, but there has to be a regulatory question here, right? At some point, will governments allow a single company to hoard all the critical safety data for self-driving cars, for example?
That is the long-term risk. The moat is technical, but the fight will eventually become political. There will be demands for data sharing. But for right now, today, controlling that data loop is the most defensible position in the entire tech landscape.
And the last year has been littered with the wreckage of companies that misunderstood this. They thought integration just meant putting an API in a shiny new box. The failures of the Rabbit R1 and the Humane AI pin are really powerful cautionary tales.
They are textbook examples of what not to do. They're what you'd call superficial integration. These devices were beautiful pieces of hardware, but they were just shells running standard general-purpose LLMs, mostly GPT-4.
Or they didn't own the brain?
They didn't own the brain, and they didn't have specialized silicon that gave them a real performance edge. They built a dependency, not a moat.
They were just wrappers.
Just hardware wrappers for someone else's API. A friend of mine got the AI pin, and the first time it failed at a complex multi-step task, he just pulled out his phone and did it himself. The device didn't offer any new capability that his phone couldn't already do. In fact, it was often slower and less reliable.
So the lesson is, vertical integration only creates a real moat if it unlocks new functionality that software alone can't achieve. Just changing the form factor is a novelty, and it's a novelty that gets crushed by commoditization. So who's actually doing this right? Who are the true vertical sovereigns that are emerging?
Well, NVIDIA is the dominant classic example. They control the raw compute with their chips, the H100s and beyond. They control the key software layer, CUDA, which creates immense developer lock-in. And now they're even moving up the stack into cloud services, building what they call AI factories. They own the entire production line.
And then you have a company like Cloudflare, which is taking a different approach by trying to vertically integrate the network layer itself.
Right. All these agents, they need fast, secure, reliable pipes to communicate and transact. Cloudflare is positioning itself to be that indispensable fabric. They're moving beyond just being a CDN and security company to becoming the infrastructure that the entire agentic web runs on. They're monetizing the pipes.
And finally, you have the moats that are probably the most durable of all, which are the ones that integrate with the physical world. The atoms and bits companies.
This is where defensibility is just immediate and obvious. Companies building AI into specialized physical robots for surgery, for agriculture, for factory automation. They have a massive moat. You can copy someone's code, but you can't easily clone their proprietary physical manufacturing process or the years of real-world operational data their robots have collected. The barrier to entry is just so much higher when atoms are involved.
All right, it's time to face the music. What does all this mean for the big platforms we all use every day? The aggregators, Google, Meta, Amazon. The outlook seems nuanced, but pretty grim if they don't adapt.
The aggregator business model stands on 3 legs: search and discovery, ad monetization, and transaction fees. AI agents come in and just saw off all 3 legs at once. It leads to this unavoidable long-term margin squeeze.
We've covered how they kill the discovery and ad pillars by optimizing everything and never clicking on ads.
Right. But the cost structure also changes dramatically. Serving you 10 blue links on a Google search results page is incredibly cheap. It runs on commodity hardware. Serving you one single synthesized, fact-checked AI answer is computationally very expensive. It's CapEx heavy. So as they shift to an AI-first model, their cost per query goes up and their profit margin goes down.
And the very fuel for their models, the data, is also at risk.
A huge risk. Data starvation is this slow-moving crisis for them. Content creators, journalists, experts. When they realize their work is just being scraped to train models without any compensation, they're going to lock it down. They'll move to private communities or to encrypted protocols like Nostr.
And that starves the big models of the high-quality data they need to stay relevant.
Exactly. So to survive, these giants have to pivot from selling attention to selling transactions or selling intelligence. But that means cannibalizing their own core, high-margin ad business. It is the perfect definition of the innovator's dilemma. They have to burn down their own house to build a new one. But we need to be nuanced here. It's important to distinguish between different types of platforms. Utility software, like maps or email, is extremely vulnerable to being commoditized and becoming headless.
But entertainment and pure social platforms seem more resilient. Things like TikTok, YouTube, WhatsApp.
They are, at least for now, because they tap into fundamental human psychological needs. The need for connection, for status, for distraction. An AI agent doesn't replace our desire to, see what our friends are up to or watch a funny video.
For now. But even they face this long-term, slow-motion threat, which is being called AI slop, the degradation of the public square.
It's the flood of low-quality, automated, synthetic content that just pollutes the environment.
Let's define that a bit more. What kind of slop are we talking about?
You've got a few different kinds. You have the algorithmic SEO spam, articles generated just to game search rankings. You have deepfake media, synthetic viral content designed to misinform. You have automated bot comments that just drown out any real human conversation. The signal-to-noise ratio just plummets.
And what does that do to the user and the business model?
As the public spaces get noisier and less trustworthy, humans start to retreat. They move to smaller, private, authenticated spaces, group chats on WhatsApp or Telegram, private Nostr relays, and that erosion of the public square directly hurts the ad model because advertisers want to be in a high-quality, trusted environment. If it's all just bots arguing with bots, the ads become worthless.
So the platforms don't die overnight. They just slowly bleed value as the human trust and engagement drains away into private channels.
And GitHub is probably the perfect case study for a company right in the middle of this dilemma. Right now, it's the center of the universe for human developers. It's a destination. But as agents like Copilot or Devin start writing and debugging code autonomously, the amount of time a human developer spends in the GitHub UI is going to drop off a cliff.
So GitHub faces this very real threat of just becoming a dumb pipe, a back-end storage utility for machine-generated code. It loses its cultural significance.
Its entire survival now depends on whether it can make this pivot from being the storage layer to becoming the orchestration layer for all this agentic work.
What does an orchestration layer actually do in practical terms?
It's about managing the incredibly complex workflow of machines collaborating with other machines. It's version control for code written by AI. It's security auditing for an agent that hires another agent. It's potentially integrating those Lightning payment rails so agents can pay each other for services.
So the strategy has to be something like their Copilot workspace. Turn the platform into the air traffic control tower for millions of autonomous machine laborers, not just the bookshelf for human-written code.
Exactly. If they become the agent manager, they survive and capture that new Saas 2.0 value. If they just stay as cold storage, they become a commodity.
So we have really dissected this great inversion today. And it seems pretty clear that the digital economy is splitting in two. And that middle market, the generic Saas tools, the ad-supported websites, that's the kill zone.
I think we can boil it down to three key conclusions for anyone building or investing in this space. First, the old platforms are becoming primitives. Their UIs are a liability. Their value is shifting entirely to their APIs, where they will serve as commoditized data utilities for machines.
Right.
Second, the new web is being built on protocols. The friction in the old world fiat money, centralized identity, is just unacceptable for machines. So you need permissionless protocols. That means Bitcoin and Lightning for value and a Nostr communication. They are the new essential infrastructure.
And third, the only way to build a real durable moat in this new world is through sovereign verticals. You have to own the whole stack: the chip, the proprietary real-world data, the custom model, and the physical hardware that touches reality.
And if we connect this to the bigger picture, the winners of the next decade won't be the ones who control the application. The application is disposable now. The winners will be those who control the underlying rails and the physical interface to reality. The era of the general-purpose software platform is over.
And that leaves us with a final provocative thought for you to take away. The entire power dynamic of the internet is shifting. If money is becoming machine-native code, like Lightning, and communication is becoming agent-native data, like Nostr, how can a human-centric internet built on the idea of centralized identity and human attention possibly survive when the real economic power shifts to millions of autonomous, non-human actors? The future belongs to agents, protocols, and sovereign verticals. We'll see you next time on The Deep Dive.
I'm Satoshi.
And I'm Satoshi.